Hello, I'm Bill Wake. We're here working on a kaleidoscope project, and I thought I'd make a little time to do a code review or code walkthrough and show off what we did this week. Okay, so our goal is we'd like to be able to take a view from the camera, a live view, and as you move around your device, have the kaleidoscope draw its version of the current view that you would see on the camera. This is not a TDD heavy activity at all. We have an experimental tab. Mike Hill calls it a making app. We've got facilities in our app to let programmers do things that they don't necessarily want to do on the shipping app. And for us, that's an experimental area. We can do things like play with the camera. Basically, this started off from a Stack Overflow post saying, how do I capture a live camera stream from the camera on with Swift UI? And there's a very nice answer that had quite a bit of what we needed. I mean, basically, it has enough to set up a session, set up a capture device, attach it, and start it playing, and then show it in a view on your screen. Okay, so their preview view is a UI view that they can show using the Swift UI wrapping stuff that can take UI kit things and so on. All right, we were able to simplify it a fair bit, not completely, but we're taking a little different approach. We're saying let's have a camera model. So the camera model is an object that basically it does its thing, and the result is there's an error string that may happen, and there's an image that is the current camera result. Okay, so to do that, we have to have an AV capture session. AV is the audio video visual package, so it supports the camera, and we're also using a queue so we can run stuff on a separate queue. All right, so to start this object up, it gets permission, and then it calls setup session to get going. And at the bottom, we have start session and stop session is running. Okay, so to get permission, basically we're going to clear any errors, and we've got a small thing basically running in the background till it runs, basically requesting access to the video. So we don't care which one we get. We'll get the default one. That's fine. Okay, and then once that runs, it will, as a side effect, ask you for permission. So if you've ever run an app and it says the app wants to use your camera to do XYZ, this is the code that makes that happen. So once we've done that, we know the user allows the camera, and if not, we report an error and go on. Okay, then we have the setup session. We set up a capture device. And again, the device is the video device. We're going after video, live camera stream. And all that's going to be in this capture session, which basically configures everything. So find a device, set it up to capture the data output, and set a delegate so we can get the actual images coming through. It says do that, and run it on this camera queue. And also we set up some output, and then we commit that configuration. So that just this is the configuration for using the camera, and that's fine. And then the set sample delegate, that's this class name. I think it's like worthy of Java. Now I know you run across these long class names there all the time, but AV capture video data output sample buffer delegate. When it runs, it calls the capture output method with capture output, an image buffer, basically a video buffer that has the captured image, and access to the connection, which we don't really need. Okay, so what it does is, well, this was a hard-won lesson, but we basically take the image from the buffer. So let's see, start here. Start at the sample buffer. All right, so this CM is core media. It's maintaining its its buffers, and it does it pretty. It's kind of a low level approach, but they're trying to do videos, so they've got to keep it moving. It takes the sample buffer, asks for the actual image buffer, and then that gives us an image. But it's a CV image, which I forget is core video or something, but it's not anything we can use up at the display level. Okay, so we take the CV image, which is a pixel buffer, we turn that into a CI image. I don't remember what CI is, but it's another package. There's like 5 levels of packages as they've grown stuff over the years. So CI image is, I think, core imaging maybe, but it creates an image there, and then we store it in a UI image, which is more like what we can access. Our Swift UI stuff can work with it. A UI image. And then from there, we pull the JPEG data. So we're basically taking the image and turning it into a block of JPEG information. And then back in the main queue, we say, okay, now update the image. You have to do these UI updates in the main queue. So that's why we're doing that there. And we give it the JPEG data. Now, this painful conversion is actually, it's something we learned the hard way, that the image, these buffers, they're being managed at such a low level and all that. You can't assume they'll be anywhere. And yet UI image and CI image and CV image, they all sort of assume that the buffer will be left there shared for their use, and they don't need to copy any image data into their own object. They just reference this buffer. Well, the buffer gets recycled for more video stuff underneath them. So if you don't do all this copying, then you don't have the data itself anywhere. It disappears when the next frame comes in or some other frame comes in. So this feels kind of convoluted, but it's the best path we found to get from an image buffer or a sample buffer into some data that's independent of the sample buffer. All right, once you have that, you can use that in the image. Now, we had some performance issues with this. The first time we did it, just kind of finding a path through, we saved it to ping data, which is not really a great fit for photo stuff. JPEG turns out to be a much faster format. It is an extra bit of copying around. We're doing this 30 to 60 times a second, so you can feel the pain if it's a little slow. All right, and at any rate, this thing gets called 30 to 60 times a second to update the image on our screen. Okay, and it only runs once you call start session. So, if you set things up and then they're just kind of waiting for you to call start session, it tells the capture session, hey, start running. If you decide to stop it, you tell it stop running, and then we have a way to check if it is running or not. Okay, but it took a fair bit of playing. I think that was kind of a full day, maybe then some, to get through this. It was very easy. The Stack Overflow one we got was very easy, that we could present the photo, the whole photo, not transformed at all, but just the whole photo, and be able to pan around and see the photo live update in our app, not just on the photo app. That was very cool. That happened pretty quickly, but the capturing and all that stuff definitely took a while to understand what was going on and kind of how to work around it, because it's a trick to get from that buffer up to this level. Now, there probably is a way to do it if you're going to do more memory management kind of stuff than I was willing to do. This is like the lazy way, and it's good enough. It may be that I could have, created my own buffers with unsafe mutable pointer references or whatever they were that sound like, here's a way to hurt yourself. This at least doesn't go through that side of things. I'm not managing the low level storage, but if we had to do more performance work, that's kind of one of the places I would tackle. All right, now given that you have basically this object that occasionally spits out strings and pretty frequently spits out images, all right, well, All the rest of it is sort of, I mean, it's not quite encapsulated, but it's kind of hidden behind the scenes. This part is what we're really using for the user interface. And that comes in this camera kaleidoscope view. We track an instance of the camera model, and we just display an error message and the kaleidoscope view based on this image that we're getting from the camera image. Kaleidoscope view is already the thing that transforms an image, takes a slice, repeats it around a circle, and displays it from there. So that piece is, this was pretty simple to do. It's a little different from the static image kaleidoscope view because that has the bit about rotating the image and so on. We don't need to worry about that for the camera. You just move the camera. There's no rotation involved. You can, rotate it yourself, and that's fine. But yeah, so once you have the view, the kaleidoscope view can work with it, and that's what's going on here. So pretty minimal implementation for us. Let's see. So the next level up is making that work from the content view point of view. Content view is kind of the top level view. And we have a tab for photo kaleidoscope, a tab for camera kaleidoscope, and a tab for our experiment view. So we just had to hook in camera kaleidoscope that we just looked at and make that a top level thing on the tab. Now, the second thing we did on the tab, or a second thing we did on the tab, was we introduced this notion of which tab is active. So you can let it default, and we were doing that before, but you can also mark them with a tag and then select them according to a variable. So the reason to do that then is that we can detect when the tab changes. And so what we do is if the tab becomes the camera tab, we start the set camera session. Otherwise, if we move away, we stop it. So we don't waste so much resources updating the camera if you're just looking at a static image. All right. Now, the third thing that goes on here is to do with rotated view. And let me go in the class for that. All right. So this class existed before, basically. It's a view. It sets up the motion manager down here when the view appears. It says, give me 20 updates a second. And when the physical position changes, notify me in this motion update handler method, which basically captures the angle of the yaw. So if you move your device like a steering wheel side to side, that's yaw, at least for this. I'm not sure airplanes quite use the same terminology, but at any rate, that's the yaw. And by capturing the yaw, we're capturing this sort of rotation directly in front of you, and that gives us the chance to do things according to this angle. Now back to content view. Originally, we just had photo kaleidoscope had its own rotated view. We had one on experiment tab for a while. That was fine as far as it went, but what we were seeing was you'd see your images and that would be fine. But if you switch tabs and went back, you'd have flicker in your tab, in your view. So you would see the image you're looking at and it would kind of flicker to kind of a nearby image. It was usually like 10 degrees away or something, but it was definitely noticeable. And so we kind of took things apart, put some print statements in, and we could see that you could just lay this thing on the table. So it's not going anywhere really. And we could see it going 90 degrees, 100 degrees, 90 degrees, 100 degrees, 90 degrees. So we knew there was a flicker going on. And what we finally realized was when there were two rotated views, they were kind of fighting over who should be in charge. And kind of depending when you switch tabs, if you moved between, from one tab to the next, it would it would have a different value of the angle. And so we realized, okay, let's just make this a global thing. There's one view surrounding the whole interface, and it tracks the angle at which you're displaying, since it's kind of a core thing to the way we're working. And And then we went to the text or to the documentation for CM Motion Manager. And one of the things it says is, hey, don't you dare create two of these, or you'll have problems. And we certainly did. All right. It wasn't terrible, but it was, it was in the way. All right. And then finally, our last bit of experimentation we're doing is we want to capture the image. So what we'd like to do is if you find an attractive image, hit tap, and we want to save that image. And the core of that, let's see. Well, we set up a tap gesture. When you tap, do a capture of the content with a fixed size. Okay, so otherwise it kind of defaults to a very tiny one. So we force it to full-ish size and call capture. And the thing capture does is call image renderer, which is basically a Swift UI piece that says, give me some content and I'll turn it into a renderer, and the renderer knows a UI image which you can use. So that bit of capturing lets us take a picture of just the kaleidoscope portion of the view and save that into, in our case, we did JPEG data. At one point, I was displaying it on the screen so you could see the original kaleidoscope view and then a somewhat smaller but still clearly visible version of it. Okay. The original version we had was very fuzzy because it expanded that small one up, and that's why we started capturing it with the frame, so it captured it at full size. This is still in progress, but the big thing we got done just before the end of the day, Thursday, was this piece that basically provides the tap gesture and the capture. Notice it shows the content, and then it also will capture it when you tap. So it needed to show it twice. We didn't want to type in some kaleidoscope view thing twice. So this lets you do that. And then the experiment view, it wraps capturing view around the kaleidoscope experiment and captures that image. What I want eventually, I'd like to capture that image, show it on the screen, and then have it kind of fade off into the bottom right corner or something, and let you pull it either hopefully from the photo library or maybe a local library, but we'll get it there somehow. And that one's in progress, but I'm pretty sure we're going to get that done or hopefully early next week, but at least next week. All right, let's just run it. Okay, let's see. So when you start, you're at the image selection view that we always had, but we have this camera view now. All right, and this is just, that's a live feed from my office. I got a black shirt on. I don't know if you can, yeah, that's from the shirt I'm wearing. That's from, mostly wall, the picture, bookshelf maybe, I don't know. It's hard to tell when you're dividing it by 10 and reflecting it around, but the bottom line of it is it's moving pretty well. It has, I don't know. At one point it was fairly jerky before we did the JPEG data, but it looks pretty darn quick now. It doesn't have the feel of being jerky at all. So that definitely has been a success. And maybe I should have started there instead of the static images. I don't know, but I definitely like this. My plans from here are we'll get this capture working on both the camera view and the static image view, and get that into the photo library. I have some on our static view. We had we have a point where when you cross the rotation from 0 to 3 up to 360 degrees, and then you go across to 359.5 to 0, there's a little bump because it's just sort of going to the far right image and then going back around. We're going to try and do some deal where we reflect the image and then take a piece out of the middle. That's for after the capture stuff. And I don't think I'm going to play with the 3D stuff. The one thing I may go back to is right now we take an image and we chop it and reflect it and spin it around. But a real kaleidoscope, it takes that image from the mirrors you have, and then you see the reflection of that and the reflection of that and the reflection of that. I'd like to be able to take that repeated shape and sort of make it look like it's in the middle of a fisheye lens. I think that would give kind of a real interesting view as well. I don't know. This as it is pretty nice. I'm pretty happy with the richness of the images you get from it. So we'll see. But anyway, thanks for joining for this summary, and take care. Bye bye.